Hi, Gen Chem. Today we are going to explore reaction energy in a gizmo today. This will be a little bit like the Hess's law that I taught you last time, but this time we are going to use a gizmo again. So you're going to want to put your screen, kind of split it between the gizmo on one side and your Canvas assignment on the other. So I just wanted to show you really quickly how to navigate the gizmo and what types of things that you will be able to look at and the types of things that you will be manipulating. So let's first thing go to Explore Learning. You're going to want to go to Explore Learning and you will want to log in. Now, if you have not made an account yet, make sure that you make a student account, and there are class add codes. So if you do not have your class add code, let me know and I'd be happy to email you the class add code for your class. Okay, so we're going to log in. And then once you get logged in, you're going to want to go to your class. So I'm just going to use the B1 class as an example. Okay. Then if you do this, you're going to be looking for the reaction energy gizmo. So we are going to be doing the reaction energy. It's the one that you haven't done yet. You're going to want to get this gizmo and you're going to want to launch this gizmo. So we'll launch this. Okay, so we're going to make this as large as we can. Okay, now you'll notice that there are several tabs here. We have up top, we have our tools. We can take screenshots, we can post point arrows, we can have sound tools, we can get help. We have our reaction tab where it shows our reaction vessel. This kind of a vessel is called a calorimeter. It basically is a walled vessel with some water in it, and we can see if that water cools down or heats up, whether a reaction is exothermic or endothermic. Exothermic is a reaction that releases energy. So in an exothermic reaction, we would expect that water to heat up, and we can measure that by our thermometer here. And down here, there's also a thermometer reading that we can see. Or if it's endothermic, we would expect that water to cool down. So we would expect the temperature to decrease right here. Okay. We also have an investigation tab here where we can break and make bonds. So for example, if you wanted to break bonds, you would put the molecule in there and you would click on the break bond. Okay, and then it breaks the bond between the hydrogens and it shows you how much energy was released down here. And these tools are in the way right here. So this is how much energy was absorbed, meaning you needed to put in that much energy. It was absorbed. So that was an endothermic reaction. Now, for molecules like this, you see there's two lines here. We have a double bond. So when you break the bonds, it will only break it one at a time. So you're going to have to do it twice or to break a double bond, or 3 times to break a triple bond. Okay? So that's how you break bonds. Let's do this. Let's break this one as well. So now we have everything broken into various atoms. Now we're going to create. So notice we broke the bonds of hydrogen. We broke the bonds of oxygen here. Now we're going to actually create the bonds over here on our product side. This is our reaction that we're doing right here to make the water. So it gives you a template. So obviously the big circle is the oxygen. So we're going to put the oxygens here, and we'll put a hydrogen here, and we have to create a bond. And it gives us how much energy is released exothermic when that bond is created. And then we'll put another hydrogen in here, and we'll create that bond, and we'll see that energy here. So we had all the energy absorbed by breaking those bonds and all the energy released by making those bonds. But notice we're going to have to make 2 waters to do this, to use up everything. So we'll create that bond, and we'll create this bond, and notice we have the total of all the energies for breaking all of these bonds, and the total of all the energies for making these bonds. So the difference between these 2 totals down here at the bottom will give us our delta H, or the heat or the enthalpy of a reaction, whichever way you want to talk about it. Okay? Now, that's one way we can look at this, and we are going to explore different reactions doing this. We can also do this in the reaction vessel. We can press play and see what happens when we have this reaction going on. We can switch reactions around and press play and see what reactions have going on. So notice this reaction, we had a sound, we had a flash of light, and the temperature raised. We started at 21 degrees and we're at 27.4 degrees. So we actually absorbed some heat as we made that water. So all of these things, you're going to be testing out these reactions. Reaction 1, 2, 3, and 4. And you're going to be playing around with breaking and making the bonds and using the reaction vessel to see which reaction happens forward or reverse. We can make it forward or reverse. We can do all kinds of things with this. So these are the things that we are going to be manipulating throughout this thing. So you will find your directions on how you need to set things and what things you need to read and what data you need to get off of this in your Canvas assignment. So make sure that you split your screen between your Canvas assignment on one side and this Gizmo is on the other side so that you can get the data and the directions of how you are going to be doing these things. And also you have a readout of energy here as well. Okay? So there's all kinds of different things going on. I hope you enjoy this, and I hope it makes figuring out the reaction energy a little bit easier. Talk to you later. Have a great day. Bye.